Hello dear viewers, today's video is just for the evaluation of logarithms, and it's more of a connection from our previous video. Now in this video we will be looking at how we can use a format to convert the logarithmic equations to exponential equations, and we'll be using a variety of numerical understanding. So we'll use roots, we'll use whole integers, we'll use a variety. So we'll get to know that during the video. So I'd like to dedicate this video more of the application of logarithms, the most fun part of this. So hopefully this video will be most enjoyable. To start off, I'd like to start off with an example. So the example refers, we have log base 7 of 49. Now they've asked us to evaluate this. Let's just put this as x. Alright, so from our previous lesson we've understood that this is the base, this is the argument, the answer, and this is the exponent. Now let's put this in the format. So we have the base to the power of the exponent equates to the argument, and as we know, 7 times 7 is 49. That means 7 power 2 equates to 49, so x is 2. Alright, that's our first example, and that seemed pretty good. Let's go for the next step onwards. Let's see if you could use fractions now. Let's say log base 2 of, let's say, 1 upon 4. Now let's see how to solve this. So we know that log base 2, so 4 could be represented as 2 power 2, so that's 1 over 2 power 2 is equal to x. So let's just keep on simplifying the solutions we have here, and finally we would be able to get an answer. So far we have log base 2 of 1 upon 2 squared is equal to x. Now let's simplify it even more. Log base 2 of 2 power negative 2. So this is a fraction, this is the power rule. So 1 upon 2 squared is 2 power negative 2. And this is basically this, but represented through a different format. So log base 2 of 2 power negative 2 equates to x. Now let's see how this could be written as an exponential equation. So 2, so this is the base, exponent, and the argument. So 2 power x equates to 2 power negative 2. Now you would be wondering, how do we get the value of x from this? Simply, we look at the exponents available. We have x here and we have negative 2 here. That means x simply equates to negative 2. And that's done. So x is negative 2. Let's look at another example. Let's incorporate the roots and the surds. So log, and then you would have base 6, and let's say root 6, and of course equates to x. How do we format this into an exponential? So we would then have 6 power x is equal to root 6, but we couldn't just directly get the value of x by here. So instead, let's now simplify it even more. So log base 6 of, so root 6 could also be written as 6 to the power of 1 upon 2, and this equates to x. Alright, now Just the same way we've done to the previous question, let's put this into the exponential format. So 6 power x equates to 6 power 1 upon 2. And visually, we could say that x equals to 1 upon 2. Perfect. Let's go a bit more to our last question. Let's incorporate surds as well. Log base 2 of 1 upon root 2 equals to x. So that is 2 power x is equal to 1 upon root 2. Again, we can't just get the value of x by here. So let's, for our ease sake, let's just simplify the numericals to the easiest we can to solve for the value of x. So we would have log base 2 of 1 upon 2 power 1 by 2. We're just using these exponents as we've referred to the previous questions. So log base 2 of 1 upon 2 power 1 upon 2 equates to x. Now what's the next step? Let's simplify it once again. Log base 2 of, and now here, as we know it's 1 upon a value, we can simply put 2 power negative 1 upon 2. For all cases, whenever you have 1 upon x, it becomes x power negative 1. That's the alternative format of writing this. Back to the question. Now we've got our fundamentals. We've got 2 power x is equal to 2 power negative 1 upon 2. That leaves us with x to be negative 1 upon 2. That's perfect. So this is pretty much a summary of our entire class. I hope you've learned something new, and make sure you stay tuned for the next few videos because I'll be covering a few more topics on logarithms.